What is a first order linear equation? Now, a first order linear equation is written as dy dx plus py, and that is equal to q. Now, for this equation, p and q, they are functions in terms of x. So I could well write it as this. So p and q, they are functions in terms of x. Now, if you were given this equation and you were required to solve it, that is to solve the first order linear equation, how are you going to solve it? What is the way that we need to take in order to solve this equation? So the first thing you need to do, you need to introduce another variable, and in this case the variable is going to be this symbol, that is rho. And basically we're going to take this variable and multiply it through both the left and the right hand side of the equation above, this one. Now if we multiplied the equation by rho, this is what we're going to have. So rho multiplied by dy dx, that is going to give us rho dy dx. And rho multiplied by this, we're going to have a rho py. And on these other side, if we multiplied rho by q, we're going to have a rho q. Now we need to hold this equation also at the back. Next up, we need to take rho multiplied by y and find out what is going to be the derivative of this function with respect to x. So in this case, we're going to take rho to be one function and y would be another function. Now, after finding the derivative of this, we need to equate that to rho q. So this is what we're going to do. We have d rho y, that is the derivative of this with respect to x. We need to make that to be equal to rho q. So let us find out what is going to be the derivative. Now, because we have these two functions as different functions, we're going to use the product rule and differentiating it. So that is going to give us rho dy dx for the first term. And for this second, we're going to have y d rho dx. And like we said, all these should be equal to rho q. So this is another equation created. Now notice that we have rho q on the right hand side of this previous equation. And we also have a rho q for the right hand side of the new equation. That means the left hand sides of these two equations are actually equal. And so we can actually equate them. So since we have rho q to be equal to rho q, that is ultimately going to give us rho dy dx plus rho py, and this is equal to rho dy dx plus y d rho dx. Now from here we have rho dy dx present on both sides of the equation, so we could well cancel them out. So that should give us a new form of the equation. Well, so I need to take only this one out. So that leaves us with rho py, that is equal to y d rho dx. From here also we find out y is present on both sides of the equation. So we could also cancel these ones out. So that leaves us with rho p, that is equal to d rho dx. Now notice that we have a derivative in terms of rho, and there is also a variable rho on the left hand side. So we just need to rearrange this equation in such a case as taking dx to this other side and bringing rho to the other side. So I think I'm just going to take it up gradually. First off, we're going to multiply through with dx, and so that will take us to rho p dx, and that will be equal to d rho. Next up, we're going to divide through by rho. So that gives us p dx rather, and this is equal to d rho divided by rho. So I think I could well wipe these up. So from here, we have that 1 over rho. That is equal to, well, I need to add up the d rho there. So this is equal to p dx. This is what we got. Now the last step is actually to take out the derivatives of the variables in this place. Now in order to do that, we need to integrate both sides. So that is going to be integral of 1 over rho d rho. And this will be equal to integral of p dx. Okay. Now for this other part, we know that the integral of 1 over rho, that should give us ln rho plus c. So instead of leaving it as a normal c, I would just leave it as a natural logarithm of c, because this is basically a constant also. Ln means log to the base e, and so you have c as a constant. So the natural logarithm of a constant, that is still going to give us another constant, basically. And on this side, we do not really know what the function p is, so we're just going to have a integral of p dx. Now, if you have two natural logarithms added, you could well take them together. And so that would give us ln rho c. So this is what we should have. I need to bring this together. So this is equal to integral p dx. Now, I know that ln is the same thing as log to the base e. And so that is log to the base e multiplied by rho c. And that will be equal to integral p dx. Now, I could well change this logarithmic equation into an initial one. That is by taking the power of the exponential as this stuff. And that will be equal to this stuff on the other side. So basically, we're going to have e raised to the power of integral p dx. This would be equal to rho c. Now, this is actually the general equation, but we want to express it in specific terms. That is in such a case as having c, that is a constant, to be a unity. So if we make c to be 1, that is the constant, we're going to have a new form. So that will be e raised to the power of integral p dx, and that is equal to rho. So this stuff, which you see here, this is what is called the integrating factor. This is the most important stuff which you need to have in order to solve a first order linear equation. The integrating factor is written as rho. So I'm going to write it as IF. That is the integrating factor. For every equation, which is a first order linear equation, you need to find out what is the integrating factor, and from there you can go on to solve the question. Now, immediately you have actually found out what is the integrating factor, you need to work out what is the derivative of this. That is the integrating factor multiplied by y with respect to x, and this must be equal to rho q. So in this case, we need to find out what the rho is, and this will be the way to find out what the rho is. You need to find out p, that function which is in terms of x, and find the exponential raised to the power of the integral of that function with respect to x. That is going to give you the integrating factor. Now, you're going to have the derivative of that integrating factor multiplied by y. That must be equal to the integrating factor multiplied by the other function in terms of x. Now, in order to solve this question, you need to find out what is the value of y. So finding out what y is actually the end of the whole stuff, the end of the task. So how could we find it out from here? Now, we know that we would cross multiply with dx, and that is going to give us d rho y, and this equal to rho q dx. Now I would just integrate both sides. So integrating both sides, I should have a integral d, well, this should be a rho. Integral d rho y, and here we would have integral pq. Well, this is also another mistake. I needed to write it as a rho. That is the integrating factor multiplied by q dx. Now, I know that the integral of a derivative, that is going to cancel out. So this should cancel the derivative away. And that would leave us with rho y. So rho y will be equal to integral rho q dx. And finally, finding out y, we need to make y isolated. So that would leave us with this stuff. Need to wipe this out now. So y in this case will be equal to integral rho q dx. And obviously finding out the integral of this stuff must certainly give us a constant. So we just need to add the constant there. And then we need to multiply that with the inverse or the reciprocal of the integrating factor. So that obviously should be a rho to the negative 1. So that is how to find the solution to a first order linear equation. So we're going to take some examples to see how stuff really works. So here is the first question. Solve the given first order linear equation. So first off, we need to write out the general linear equation, the general first order linear equation. And that is written as dy dx plus py equal to q. So we need to bring out what p is. And from this place, you can well see that p is obviously equal to this whole stuff because we have a positive being after the dy dx. So that should well be the 3 divided by x, bringing the minus. And we're going to have q to be equal to x right there. So for 1, we know that p is equal to minus 3 divided by x. And secondly, we know that q is equal to x. Now the next thing we need to do, we need to find out what is the integrating factor. So the integrating factor, that is equal to e raised to the power of integral p dx. Now we know what p is. So this is going to be e raised to the integral minus of 3 divided by x dx. Now I have this to be a constant which is multiplied with the variable 1 over x. So I'm going to take that out and that will be minus 3. Okay, so I need to rewrite it. This is going to be e raised to the power of a negative 3 integral 1 over x dx. Now we know that the integral of 1 over x, that should give us ln x. So this is what we're going to have. Rho is equal to e raised to the power of a negative ln x. Now from the laws of logarithm, we know that negative 3 could well go to the power of the subject of the natural logarithm. So this should give us rho equal to e raised to the power of ln x to the negative 3. Next up, there is a law that if you have ln, well, that is e to the ln a, the answer is going to be a. If you had e raised to the power of ln a to the m, the answer will be a to the m. So typically you want to cancel out the e with its natural logarithm, and everything left would actually be the answer for that operation. So we're going to use this understanding to find out the answer for this. That is the integrating factor. That is going to be x raised to the power of a negative 3. Now next up, we need to find what y is going to be. So how could we do that? Now you know that to find out what y is going to be, you ought to have a d dx of rho y and that be equal to rho q. Now from here we need to have d rho y is equal to rho q dx, and then we need to integrate both sides. So integrating this side, this left hand side, we're gonna have rho y, and that will be equal to integral rho q dx, right? So we already know what rho is. Rho is x to the negative 1, and we know what q is. Q is equal to x, as was written initially. So we should have something like this. This is rho y, and this will be equal to integral x to the negative 3 multiplied by x and dx right there. So we should have rho y is equal to integral x to the negative 2 dx. Negative 3, or x to the negative 3 multiplied by x, that should give us x to the negative 2, because we know this is going to be to the power of a 1. So this is what we should have for the left hand side. And so now we need to integrate this side. Now integrating this side, that is going to give us this. So we basically want to use the power rule of integration. So that is going to be integral x to the negative 2 plus 1. I think I'm going to take these away. I need to write it out somewhere. So we actually have a rho equal to x to the negative 3. Just need to place it somewhere here. So this is what we got, and that will be divided by negative 2 plus 1 plus c. So rho y is equal to x to the power of a negative 1 divided by negative 1 plus a c. So y is going to be equal to negative x to the negative 1 plus c. Now from here we know that this is going to yield a negative 1 over x, because x to the negative 1 is the same thing as 1 over x. Well, you already have a negative in front of it, so that should give you negative 1 over x. So rho y is equal to negative 1 over x plus c. And finally we need to take rho to the other side. So y is equal to negative 1 over x plus c multiplied by rho to the negative 1. Now we know what rho is. Rho is x to the negative 3. So y will be equal to negative 1 over x plus c multiplied by x to the negative 3. And this is all raised to the power of a negative 1. Now negative 3 multiplied by negative 1, that is going to give us a positive 3. So y is equal to negative 1 over x plus c, and that will be equal to x raised to the power of 3. So this is the solution to this first order linear equation. This is going to be the answer. Now here is another one for you. Find the solution to this first order linear equation. Now from here we can actually find that we do not really have dy dx combined. So we need to make that work. Now how can we do that? First off, we need to take dx and bring it to one side or keep it together. So I could well take this to the other side, and that would give us x dy is equal to sine x dx. So that is going to be sine x dx minus y dx. And from here we could well factor out dx. So we're going to have x dy, and that will be equal to sine x minus y, and you're going to have dx on this other side. So I need to divide through by dx. Now doing that, we're going to have x dy dx, and on this side we're just going to have sine x minus y left on the right hand side. Now we also need to take this away, so we just need to multiply through by 1 over x. So that is going to be 1 over x. So this is dy, well, that is x multiplied by dy dx, on this side, we're going to have sine x minus y. Now we know obviously multiplying this by this term for the left hand side, that is going to cancel these one out. So that leaves us with dy dx. And so on this other side, we're just going to have 1 over x multiplied by that. So that is dy dx. So this is going to be equal to sine x minus y multiplied by 1 over x. So dy dx is going to be equal to sine x multiplying 1 over x by sine x. That will leave us with sine x divided by x. And here we're going to have a y divided by x. Okay, so closer and closer, we're actually moving to the real form of the first order linear equation. Now you know that the function which is always left on the right hand side of the first order linear equation, it's always a function solely in terms of x. So this one qualifies for that. So we're going to take this back inward, that is to the left hand side of this equation. So that would give us dy dx, and here we're going to have a positive y over x. That is equal to sine x divided by x. So this is going to give us dy dx plus 1 over x multiplied by y. This is equal to sine x divided by x. So that will be the real form of this first order linear equation. Now from here, we know that p is equal to 1 over x, and q is equal to sine x divided by x. So we need to find out what the integrating factor is. As we said, that should be equal to e raised to the power of integral p dx. Now what is e? Well, rather I needed to ask for what p is. Now p is 1 divided by x, and we have dx there. So this is obviously e to the ln x. Now of course, like we said, this is going to cancel these out. So that will leave us with the x. So in this case, we say that the integrating factor is equal to x. Now, like you well know, we're going to have rho y to be equal to integral rho q dx. So we have rho to be equal to x, and q, that is equal to sine x divided by x. And this is multiplied by dx. So obviously this cancels these out. So that leaves us with integral of sine x dx. And this is going to give us a negative cos x. So rho y is equal to negative cos x plus c. So finding out y, we need to divide through by the integrating factor. So, well, I would write it over here. Y is obviously equal to negative cos x plus c multiplied by rho to the negative 1. So what is rho? Like we said, rho is equal to x. So this should be y. Y will be equal to negative cosine x plus c, and that is multiplied by 1 over x, because we have we're gonna have x raised to the power of a negative 1. Now you might well leave it that way or write it as 1 over x. Whichever way you write it, that is actually gonna be correct. So in this case, this will be the answer to this question. Y is equal to negative cosine x plus c multiplied by x to the negative 1. Now here is another one for you. Feel free to pause the video and try doing it by yourself. Now, the first thing we need to do, we need to write out the general first order linear equation, which is written as dy dx plus py, that is equal to q. In this case, we can find that the first term doesn't really just look exactly as this. So we need to take the x away from there. That will be by multiplying through by the reciprocal of x. So that should be 1 over x. I need to multiply that with this. That is going to be x dy dx plus 3y. And on this side, I need to multiply that also. So this is going to be, so this is what you got. Now, if I took 1 over x and multiplied it with this first term, that is going to help us cancel these x. So we're just going to have a dy dx. And on the other side, we have a 1 over x. Well, so I need to take that out. Now, we have 1 over x multiplied by 3y. That should give us 3y divided by x. And this is going to be equal to sine x divided by x multiplied by x squared. That gives us x to the third. So this is actually the new equation that we're going to have. So this is what we need to analyze and bring out what P is as well as Q. So in this case, we find out this is going to be rewritten this way. This is dy dx, and that is plus 3 over x multiplied by y. And here you're going to have a sine x divided by x to the third. So from here, we know that P is equal to 3 over x, and Q, that is equal to sine x. So I need to rewrite that. Sine x divided by x to the third. Now, what is the next step that we need to take? We need to find out what the integrating factor is. Now, we know the integrating factor, rho. That is equal to e raised to the integral p dx. Now, rho is 3 over x, and this is multiplied by dx. Obviously, this is going to be e to the power of 3 multiplied by integral 1 over x dx. And of course, this is going to give us ln x. So this is e to the 3 ln x. And of course, this gives us ln x to the third. Now, of course, you know this is going to change. So we should have x to the third as the answer for the rho. So I'm going to add that here. Rho, that is the integrating factor, that is equal to x to the third. Now, next up, we need to find what y is. Now, from derivations from the beginning parts of this video, we said that y, you could find y by taking this, that is integral rho q dx plus c, that multiplied by rho raised to the power of a negative 1. So that is basically what we're going to do. Now, what is rho? Rho is sine x divided by x cubed. And this is multiplied by, well, that is actually a mistake on my part. Rho is equal to x to the third, actually. And so q is sine x raised to the power of 3. And this is multiplied by dx. So of course, integrating this, that should certainly create a constant. So we just need to write it there for the sake of less work. Now, rho is this. So that should be x raised to the power of a 3. And this is equal to the power of a negative 1. Now, from here, we notice that x to the third should cancel x to the third as a denominator. And that should leave us with integral sine x. Now, what is integral sine x? What is that going to give? Now, integral sine x should give us a negative cos. So I need to write it here. This is going to be negative cos. You would have a negative cos x. And of course, there should be a c. And so on this other side, we're going to have x to the negative 3. That is because multiplying 3 by negative 1, that would leave us with a 3. So this is actually the answer to this question. Y is equal to a negative cosine x plus c, and all multiplied by x raised to the power of a negative 3. So that will be the final answer. Now here is the third question. 2 dy dx minus y is equal to this stuff. And so we need to find out what is the solution to this. Now first, as you know, we need to rearrange this equation until it looks like a first order linear equation. That is dy dx plus py being equal to q. And so in this case, if we wanted to do that, we would actually need to divide through by 2. And so that should give us dy dx minus y divided by 2. And this is going to be equal to 1 over 2 e to the x divided by 2. That is what we have. Now from here, we do not really have any value of x for y there, but we could rewrite this as dy dx minus a half y. This is equal to e to the x divided by 2, all divided by 2. So what is going to be p in this case, and what should be q? Well, in this case, we do not really have no y's here. Well, no x's there. So we're just going to see that p, let it be equal to a negative half. And we're going to have q. So q will be half e to the negative, well, to the power of half x. Basically, that is what this part looks like. That is what it is. Next up, we're going to find out what the integrating factor should be. So the integrating factor, that must be equal to e raised to the power of an integral p dx, right? So this is e raised to the power of integral negative 1 over 2 dx. So this is going to give us e up to the negative half x, basically. And that is what we have. So we're just going to place it there. If you don't want to write it that way, you could also write it this way. That should give you 1 divided by e raised to the power of x divided by 2. So that is what you're going to have. Now next up, we need to find what is the value of y. Now like we said, y must be equal to the integral of rho q dx, of course, plus c multiplied by integral to the negative 1. That's the integrating factor rather. Okay. So y is going to be equal to integral rho. Now rho in this case is equal to e raised to the power of negative x divided by 2. And we have q. So what is q? Q is obviously here. That is e to the negative x divided by 2 dx. Okay, so I need to wipe these out also. Clear these also. So that is plus c. And this is, well, I need to multiply that with the negative. So we have a rho. Rho is equal to e to the negative x divided by 2. This is multiplied by negative 1. So that is what we got there. I could well wipe these out also. Now, if we multiply this, what is going to be the answer? So we're going to have e raised to the power of a negative x divided by 2 plus x divided by 2. Multiplying these two stuffs, this is what we're going to have. From the laws of indices, you should add the powers of the similar bases. Now, negative half x plus half x, that will give us e to the 0. Because this is going to give us a 0. So we have e to the 0, and that would give us a 1. So y is equal to integral 1 dx plus c. That is multiplied by e raised to the power of x divided by 2. Negative half x multiplied by negative 1. that should give us a positive half x, or x divided by 2. Now, what is the integral of 1 dx? That is going to give us x. So we basically have an x plus c. And like we said earlier, this is equal to, well, this is rather multiplied by exponential x divided by 2. So this is the answer to this question. Y is equal to x plus c multiplied by e to the power of x divided by 2. Now here is another one for you. Find the solution to this first order linear equation. Now from here we can actually find that we do not really have dy dx combined. So we need to make that work. Now how can we do that? First off, we need to take dx and bring it to one side or keep it together. So I could well take this to the other side, and that would give us x dy is equal to sine x dx. So that is going to be sine x dx minus y dx. And from here, we could well factor out dx. So we're going to have x dy, and that will be equal to sine x minus y, and you're going to have dx on this other side. So I need to divide through by dx. Now doing that, we're going to have x dy dx, and on this side, we're just going to have sine x minus y left on the right hand side. Now we also need to take this away, so we just need to multiply through by 1 over x. So that is going to be 1 over x. So this is dy, well, that is x multiplied by dy dx. On this side, we're going to have sine x minus y. Now we know obviously multiplying this by this term for the left hand side, that is going to cancel these one out. So that leaves us with dy dx. And so on this other side, we're just going to have 1 over x multiplied by that. So that is dy dx. So this is going to be equal to sine x minus y multiplied by 1 over x. So dy dx is going to be equal to sine x multiplying 1 over x by sine x. That will leave us with sine x divided by x. And here we're going to have a y divided by x. Okay, so closer and closer, we're actually moving to the real form of the first order linear equation. Now you know that the function which is always left on the right hand side of the first order linear equation, it's always a function solely in terms of x. So this one qualifies for that. So we're going to take this back inward, that is to the left hand side of this equation. So that would give us dy dx, and here we're going to have a positive y over x. That is equal to sine x divided by x. So this is going to give us dy dx plus 1 over x multiplied by y. This is equal to sine x divided by x. So that will be the real form of this first order linear equation. Now from here, we know that p is equal to 1 over x, and q is equal to sine x divided by x. So we need to find out what the integrating factor is. As we said, that should be equal to e raised to the power of integral p dx. Now what is e? Well, rather I needed to ask for what p is. Now p is 1 divided by x, and we have dx there. So this is obviously e to the ln x. Now of course, like we said, this is going to cancel these out. So that will leave us with the x. So in this case, we say that the integrating factor is equal to x. Now like you well know, we're going to have rho y to be equal to integral rho q dx. So we have rho to be equal to x and q, that is equal to sine x divided by x, and this is multiplied by dx. So obviously this cancels this out, so that leaves us with integral of sine x dx, and this is going to give us a negative cos x. So rho y is equal to negative cos x plus c. So finding out y, we need to divide through by the integrating factor. So, well, I would write it over here. Y is obviously equal to negative cos x plus c multiplied by rho to the negative 1. So what is rho? Like we said, rho is equal to x. So this should be y. Y will be equal to negative cosine x plus c, and that is multiplied by 1 over x, because we have we're gonna have x raised to the power of a negative 1. Now you might well leave it that way or write it as 1 over x. Whichever way you write it, that is actually gonna be correct. So in this case, this will be the answer to this question. Y is equal to negative cosine x plus c multiplied by x to the negative 1. Now here is the last question for this class. Feel free to pause the video, try doing it by yourself. So let us go on. Now, as you well know, we need to have dy dx isolated in this form. We need to have a dy dx plus p py, and that equal to q. So how could we well take this away from the first term of the left hand side? We need to divide through by that. So doing that, we're going to have a dy dx plus xy divided by 1 plus x. And this will be equal to 1 plus x raised to the third divided by 1 plus x, typically raised to the power of 1. So we're going to have this cancel out one of the powers, and that would leave us with a squared. So now we should have a dy dx plus x divided by 1 plus x. This is basically what we're going to have, and that will be multiplied by y. And on the other side, we're just going to have 1 plus x raised to the power of 2. So here we could well see what is p and q. So p from here, that is x divided by 1 plus x. And q is equal to 1 plus x all raised to the power of 2. Okay, so I'm going to clear these out. Next up, we need to find the integrating factor. That is equal to e raised to the power of p dx. Now we know what p is. So p in this case, that is x divided by 1 plus x, and that is multiplied by dx. So in this case, we need to integrate this. So let us work that out. Integral x divided by 1 plus x dx. What is going to be the integral of this expression? Now, first off, we need to use the substitution method to find out the integral for this. So let us say u is equal to 1 plus x. Now, if you have u equal to 1 plus x, that means x will be equal to, u minus 1. That is, if I took this to the other side, that would give us a negative 1. So that would be u plus 1. And since we find out this equation is completely commutative, we could well write it as x equal to u minus 1. That is the same thing as saying u minus 1 is equal to x. Now, we have 1 plus x as u. We need to find out what dx is, because in this case, we're just trying to take out what you have as dx. So dx is from the initial expression. We need to take it out. So I'm just going to differentiate this one, and that would pretty much take us there. So dx here, that is dx du. I could well write that. I might leave it. That is differentiating this subject with respect to this stuff. So we got u to be the variable under consideration. So differentiating u, that is going to give us a 1 because we have this as dx du. So what I'm going to do, I will just leave it as dx du for clearer understanding. That is differentiating this with respect to u, and u, the derivative of it with respect to itself, that is going to give us a 1. And the derivative of -1, because we have it as a constant, that is basically going to give us a 0. So that wouldn't add up 9. So in this case, we're going to say that dx is equal to 1 multiplied by du. So that is basically equal to du. This will be very important. So the next thing you need to do, we just need to take all these values and plug them back into the original expression. So we should have integral x. Now x in this case is u minus 1, and that is divided by 1 plus x, which we have called as u. So that should be a u. And dx now is going to be du, right? So this should be integral u divided by u minus 1 divided by u. And this is going to be du, right? So here we can find out there could be simplification. So this is basically going to give us a 1 minus 1 over u du. So the integral of 1 with respect to u, that is going to be a u. And the integral of -1 over u, that is a negative ln u. So that is what we're going to have. Now we already know what u is. We said u is equal to 1 plus x. So we really need to write that out. So u, that is 1 plus x minus ln 1 plus x. This is going to be the answer. So what we know is the integral of this stuff. This is it. So I'm going to take this. Okay. But I will just write it in this second part of the board. So that is 1 plus x minus ln absolute 1 plus x. So that is what we got for the integral. Now I'm going to take this out as well as this. Whoa. So what do we get? We said the integrating factor, that was integral e to the integral x divided by 1 plus x dx, right? Now we have this to be equal to this stuff. So we would actually need to work it out. So rho is equal to e raised to the power of 1 plus x minus ln 1 plus x. Now from the laws of indices, we could split this and have rho equal to e to the power of 1 plus x divided by e raised to the power of ln 1 plus x. Now we already know that e could well cancel ln, and that will take us to e to the 1 plus x. This is divided by 1 plus x. So in this case, we say that rho, the integrating factor, that is equal to e to the power of 1 plus x divided by 1 plus x. So that is what you got. This will be very handy as we try to solve it. And the last step is to find out what y is. Now we know that rho multiplied by y, that is equal to integral rho q dx, right? So y should be equal to integral rho q dx. Well, I'm just going to leave it because obviously we should form a constant. And that will clearly come out as we integrate it. So this is multiplied by rho to the negative 1. As we take rho to the other side, that should become a negative 1. So we know this is what rho is. We just need to plug that into this equation. So that is integral rho, which is e to the power of 1 plus x divided by 1 plus x. This is multiplied by q. This is q. And so that is 1 plus x raised to the power of 2. And so that is what you got. And this is multiplied by rho to the negative 1. Now here we can find out this could cancel one of these out. So that is what we're going to have there. Okay, so I think I need to wipe these out. So y is equal to integral e raised to the power of 1 plus x multiplied by 1 plus x and dx. And this is all multiplied by rho to the negative 1. So we need to work this out. Now simplifying, you would have y be equal to integral e to the 1 plus x. That is, I'm going to take this, multiply with 1. That gives us this stuff. Next up, I will take this and multiply with x. So that is going to give us x e to the 1 plus x. So that is what we have. Now, I need to work it gradually. So y is going to be equal to integral e raised to the power of 1 plus x dx plus integral. So I'm going to rewrite this here. We know that this should be multiplied with rho to the negative 1. Now here we should have x multiplied by e raised to the power of 1 plus x dx. So how could we solve this? We know that this must be multiplied by rho to the negative 1. So how can we solve this part? Because this part is not really hard. We know that that should give us e to the negative, well, not a negative. That should be e to the power of 1 plus x. But here we actually have some in front of that. So we're going to use integration by parts to work this out. Let us do that. So integral x multiplied by e raised to the power of 1 plus x. So we know the formula for it is integral u dv is equal to uv minus integral v du, right? So in this case, we have we're going to make u that will be equal to x. And so du is obviously going to be equal to 1. That will be 1 dx, because we should have this as du dx equal to 1, which is the same thing as du equal to 1 plus, well, 1 dx. So I'm going to take these out also. Yep. Now we have to work this. So we're going to have a dv is equal to e to the 1 plus x dx. Now, if you are not really familiar with integration by parts or substitution method, I have actually uploaded videos exactly for that. So feel free to check out my channel. As a matter of fact, I have actually linked up those videos in the description section. So feel free to check that out and just go through integration by parts, by substitution method, and you'd be able to understand everything that we're doing here. Okay, so well, before we solve this, we need to take back well, not take back, we need to recall what the integrating factor was. So what was that? What did we actually find? So remember, rho was equal to e raised to the power of 1 plus x divided by 1 plus x. This is what we had for rho. We just need to place that there. Okay. So going back, we need to work the integral of this because this is a differential, so we need to change it. And so we need to integrate both sides dx. Now we know that the integral of a derivative, that is going to cancel out, and that reduces to a v. And on this side, we're pretty much going to have e to the 1 plus x. Now, we know this should work. We should have it as divided by the derivative of the power. But in this case, the power is a 1. So that wouldn't really matter. So that will be the answer for V. So we need to work this. That is integral u dv. That is equal to uv minus integral v du. Okay. So I need to take this out also. So let us plug it in. Now u is x, and v. What is v? V is equal to this stuff. So that will be e raised to the power of 1 plus x. And that is a minus integral v. V, we already know that to be 1 plus x. And so you have it multiplied by du. Du in this case is equal to 1 dx. So we're just going to write 1 dx right there. So I need to wipe this out also. So this gives us x e to the 1 plus x. And this will be minus the integral of e raised to the power of 1 plus x. That should give us e to the 1 plus x. And that multiplied by 1. We already know 1 is a coefficient which really doesn't move anything. So this is what we got, plus c. So that will be the integral. Very important. So this is the integral of x e to the 1 plus x dx. Now we know that initially what we had was y. Y was equal to integral e to the 1 plus x dx plus integral x multiplied by e to the 1 plus x dx, right? And this was multiplied by root to the negative 1, right? So in this case, we need to bring it back into perspective. We need to work the integral of this, which is pretty much this. It's not really going to change. So we're going to have y be equal to integral of e to the negative, e to the power of 1 plus x rather. And so that is going to give us e to the 1 plus x. That is what we're going to have there. And over here we have this to be the whole of this. So that is x multiplied by e raised to the power of 1 plus x. And this is minus e raised to the power of 1 plus x. Now we know these two stuffs, they're going to cancel out. So this is plus c. And we need to multiply with rho inverse. Now if we reciprocated this stuff, this should be 1 plus x. And that is divided by e raised to the power of 1 plus x. That is what we're going to have. So the final answer is equal to this. That is x multiplied by e raised to the power of 1 plus x plus c. And that is multiplied by 1 plus x divided by e to the 1 plus x.